We're on our last video for lesson 24 about lines and angles. We're going to be talking about using logical reasoning, assumptions, and using equations to find angle measures. This is 24D. And of course, I've got the other ones linked in the description to help you, along with some middle school math videos. An assumption is a statement that is accepted to be true without question or proof. And in math, assumptions are conditions that are assumed to be true for all calculations. We use logic, common sense for these calculations. But be careful. Don't just base your conclusions on the appearance of a diagram. Make sure that you have mathematical reasoning to support your conclusion. So take a look at this drawing here. We've got these blue lines, and we can see there's some angles here. And it's telling us that this is a 150-degree angle right here. But it also says on the side that it's given that angle ABC is a straight angle. So we know that this is 180 degrees, don't we? Because that's a definition of a straight angle. Well, if this is 180 degree straight angle and that's 150 degrees, we can assume that that is 30 degrees because they're supplementary, right? So watch out for little things that help you use your logic, okay? Now, there'll be problems that involve complementary and supplementary angles that will need algebraic reasoning to solve. So here we've got this drawing, and we can see we've got angle 1 and angle 2, and I have an x and a 2x here, and I'll show you why. It says the measure of angle 2, this one, is twice the measure of its supplement. So that's a clue. If there's supplements, then we know that's a straight line, and it's 180 degrees. So now we can just assume that that's the 180 degrees. If that's angle 2 and that's angle 1, and this is 2 times the measure of this one, we can say this is x and that's 2x. We can let the measure of angle 1 be x and the measure of angle 2 be 2x because it's twice 1, see? We know supplementary angles equal 180 degrees. We have our equation. We have x plus 2x equals 180 degrees. This plus this should be 180. We combine the like terms. If we have an x and we add 2x, we have 3x. Now we have 3x equals 180 degrees. We divide both sides by this coefficient 3 to get the x alone. And same numerator and denominator, so we have a 1. We have 1x. We divide this by 3 and we get 60. So we know x is 60. Well, if the measure of angle 1 is 60, and this is 2 times x, that must be 120. See? Common sense, logic, right? If that's 60 degrees, then that means angle 1 is 60 degrees, and because angle 2 is 2 times it, it must be 120. See? Okay, now we have one angle is 32 degrees more than its complement. That's a clue. We know complements equal 90 degrees, don't we? If the smaller angle is represented by x, write an equation to find the measure of the smaller angle. So one angle is 32 degrees more than its complement. So we know if we think the angles are complementary, so they total 90 degrees. The larger angle is 32 degrees more than the smaller one. We know we can imagine this in our head, right? Because they're complementary, they're 90 degrees. And x is the smaller one. We have our equation. It wants us to find the equation or write an equation for this. So that means we have x, that's the smaller angle, plus x plus 32 would equal 90. Because one angle is 32 degrees more, see, than its complement. So that's the complement, and that's the one that's 32 degrees more. Now be careful, because if you have a choice of equations, it could also show up as 2x plus 32 equals 90, because they combine the like terms, see? So it could show up like that as an answer that you could choose. It also might say 2x equals 90 minus 32 because they subtracted 32 from each side. What they did was, and you've seen this before in our videos, they did the 2x plus 32 equals 90, okay, because that was the next step after combining like terms. And then they took this 2x and said it equals 90 minus 32, which is 58, see? So they took this a little step further. So these are all possible answers. If you need to choose an equation from multiple choice, think it through to each next step of the equation. So you might not recognize these right away, but if you do this on your scratch paper and then see what the next step is, you'll see, oh, that is a choice. Or if you do another step, you'll see, oh, that's a choice. See? If we complete this, we had 2x equals 58. We have to divide both sides by this 2 coefficient, don't we? We get 1x equals 58 divided by 2, which is a 29. So we know that one angle is 29 degrees and the other angle is that plus 32, so it's 61. And 29 and 61 equal 90, so yeah, it works. See? So just beware that if you have to choose these from multiple choice, that it could be another step farther into the equation, all right? Into solving it. All right? Now take a look at this one. We have a couple lines. We have line Y and line Z, and they have a transversal, this orange transversal, don't they? And it's telling us that the measure of angle 1 is 110 degrees, and the measure of angle 5 is 112 degrees. Are line Y and line Z parallel? No. If they were parallel, angle 1 and angle 5 would be congruent and they'd be corresponding angles. So if that confuses you, you need to go into this description and click on 24C and learn about corresponding angles, okay? So there's no way that they could be parallel because this one's off by 2 degrees. So don't trust diagrams unless it actually tells you in some way that they're parallel. Like, if it told us that these were corresponding angles, then we would know that these lines were parallel. See? If it was reversed and they were telling us first that they were corresponding and that was 110 and what was angle 5, then we would know that that's 110 also. But it doesn't. They're different measures, so they're not parallel, okay? And also remember to ignore unnecessary data. If we've got a drawing like this, we've got line P, line Q, line R, and line S. Can you see the parallel lines and the transversal in the diagram? It looks like this. This line and this line are parallel. These two are parallel. And then this is the transversal we're going to be working with. So we're not even working with Q. So if you can ignore this and not pay attention to it, that's what we're working with. See the parallel lines and the transversal? So be very, very careful if they throw in extra information like that. And it asks us which statement must be true if P is parallel to R. See the notation? That's the parallel symbol. So P is parallel to R. So which of these is true if these two are parallel to each other? We look at number 1 and it says angle 2 is 45 degrees. Well, we don't have any measures here to help us figure that out. We don't have any vertical measures or any supplementary measures. So there's no way of knowing that. So we don't know if that's true. So 1 is not the answer. Number 2 says angle 12 is 125 degrees. Well, here's angle 12. We know angle 5 is 125 degrees. And you know what? Angle 5 and 12 are alternate exterior angles, which means they're congruent. So number 2 is correct. If we look at the other possible choices, it's saying number 2 is 55 degrees. Well, we still don't know if that's true or not because we don't have any vertical or supplementary angles to help us answer that. It says number 4 says angle 8 is 55 degrees. Well, that can't be 55 degrees. It's a vertical angle to 5. It's got to be the same measure, 125. So 4 can't be it. Number 5 says angle 10 and angle 12 equal 125 degrees if you add them. And that can't be true because if you add them, they're supplementary. That should be 180. So the only one that could be true is number 2. And if you end up saying, well, it's not that one, and it's not that one, and it's not that one, you could do process of elimination to help you figure out if you have to guess which of the 2 would be the best guess. You'd have a better chance of getting the right answer instead of just blankly choosing one of the 5. Try to hone it down by eliminating the ones that you know don't make sense, okay? Now we have, what is the measure of angle PQR if it's 8 times the measure of its supplement? Ah, that's a clue. We know that this angle has to equal 180 degrees with the other one because there's 2 angles that are supplementary. So we think, all right, well, we're talking about supplements, and it says that this one is 8 times the measure of its supplement. So that's going to be an angle, that supplement, isn't it? So we're going to let S equal the supplement. We're going to let this angle PQR be 8S because it's 8 times the supplement, okay? Does that make sense? We use an S for supplements. We know that they have to equal 180 degrees, so we have our equation. S plus 8S equals 180 degrees. We combine like terms, and we get 9S equals 180 degrees. We divide both sides by the coefficient 9 to get the S alone, and we end up with a giant 1 here. 1S equals 20 degrees. So we know that the supplementary angle is 20 degrees, so this angle, PQR, is 8 times that. 8 times 20 is 160, and 20 plus 160 is 180, so it works. See? It's just using logic and common sense, isn't it? And the rules that we know. All right, so now I've got a bunch of weird drawings here. Take a look at this. It says given. So this is kind of you have to stare at this drawing a bit to really understand what's going on. It says given line AB. So you might see it written with just a line, and it could have little arrows on each side in some textbooks, or you might just see a plain line. That means line AB is parallel to line CD. So here's A, here's B, so that's line AB. Here's C, and here's D, so that's line CD. So it's telling us that they're parallel to each other like this. It's also telling us that angle 1 is 35 degrees right here. So we can use right angles, because it's telling us, see the box? It's telling us that those are right angles. We can use those to help us find missing angle measures. Angle 2 and angle 1 are complements that total 90 degrees. So if it's telling us that that's 35 degrees, we know angle 2 is 55. See? We just do the 90 minus the 35 degree angle 1, and we get 55 degrees for angle 2. We could even do it the equation way of saying that angle 1 and angle 2 equal 90 degrees. The 35 degrees is the measure of angle 1, so that plus the measure of angle 2 is 90. We add a negative 35 to each side to isolate this measure of angle 2. Create a 0 pair here, and we get that the measure of angle 2 is 55. See? We can also extend lines to find vertical or supplementary angles. So what I did was, if you look here, I extended this line going out farther beyond the drawing, and then I extended this one going out. So if that's 35 degrees, I can make a supplementary angle here and know that this exterior angle here is 145 degrees. See? And if this is 90 degrees together, then this one would be 90. We could figure out that that's 90 degrees, couldn't we? For this one. And this is a vertical angle, so we know that this one would be 35. See how we can find them all by extending the lines? And if you look at this as two parallel lines and a transversal, like this, and they gave us that this one was 35 degrees, and we know that this one is 145 degrees now because it's supplementary, we can find these measures because these are corresponding angles right here. See these pink ones? So we can locate parallel lines and transversals to help us find missing angle measures. We use corresponding angles. We can also use alternate interior angles. And then we know that angle 8 is 35 degrees. See? We can use vertical angles, so we know that one's 35, and that one must be 145 because it's vertical on that side. And we can use supplementary angles. We know that that's 180. That together would be 180. We can also look at it as here's the two parallel lines, and this is the transversal. See that? So your lines are all going to be black on the test, but imagine in your head, if you can, but it's got to tell you that it's parallel. You can't just assume it, because what if it's off by 1 degree and it's not really parallel, right? So this says we have a given that line AB is parallel to CD is parallel to EF. Okay, so take a look at this drawing. It's like we have a right triangle and we have 3 lines going through it, don't we? And it's telling us that this and this and this, that these 3 lines are parallel to each other. So can you see the transversals? We have a transversal here, see it? Line GH. We also have a transversal here, line HI. See that? And says if the measure of angle 4 is 120 degrees, this one, what is the measure of angle 12? Well, we can find that because angle 4 and angle 12 are corresponding angles in relation to the transversal. They're both on the same side of the transversal. This one is under a parallel line. That one's under a parallel line. So that means they're congruent. And corresponding angles are congruent, so angle 12 must be 120 degrees. See? This one says the measure of angle 6 is 20 degrees less than the measure of angle 5. So here's the measure of angle 6, here's angle 6, and here's angle 5. It says that 6 is 20 degrees less than angle 5. What are their measures? So let's let 5 be x, and 6 will be x minus 20, because 6 is 20 less than 5. See? If 6 is 20 less than 5, it's x minus 20. We have our equation. We have x plus x minus 20 equals 180. We combine the like terms, and we have 2x minus 20 equals 180. We want to isolate that x, so we start by adding 20 to both sides of the equation to create a zero pair here and get rid of it. Now we have 2x equals 200. We need to isolate the x further, so we divide both sides by this 2 coefficient. We get 1, same numerator and denominator, 1x is equal to 200 divided by 2 is 100. So we know angle 5 is 100 degrees, and if angle 6 is 20 less, it must be 80. So now we know the measures of angle 5 and angle 6. See? So look for given information in side notations like A is parallel to B, that kind of notation. Sorry about the focus. Or that line AB is parallel to CD, because then you know there's going to be some right angles, right? And don't assume lines are parallel or perpendicular unless it tells you in some way that they are, either in words or symbols. So it'll tell you that they're corresponding angles, then you know from the definition of corresponding angles, those lines must be parallel. Or it'll tell you in notation that the lines are parallel, like this, okay? All right? So be very, very careful if they're off by a degree or two. Look for some kind of notation or wording that is letting you know in some way that they're parallel. You should now be ready to do the skill focus on page 293, and then you can do that mini test for lessons 23 and 24 on pages 294 through 297, but don't use a calculator on part 2. It tells you not to, and you want to do it the way it says, because that will give you an idea of how you're going to do on the real test. You want to try to do it as closely to the real test as possible, so if they're telling you not to use the calculator, don't, all right? See how you do. Our next video is going to be all about triangles. Did you know that the 3 interior angles of any triangle are 180 degrees? Doesn't matter their shape or size, and we can find missing measures by knowing that fact. There's going to be links to the grade 7 and grade 8 videos about this topic that we just discussed, and there'll be links to the previous videos for lesson 24, all right, to help you out. So I hope you're doing okay. Keep organized. Don't move on to another topic until you really understand the previous one. So if you're having trouble with all these words, come think of a way of how you can remember all these different words: complementary, supplementary, alternate interior, alternate exterior, vertical, corresponding angles. All of those, you need to know what those mean, because they're going to be in the word problems, and they will help you. If it says they are supplementary angles, you'll say, oh yeah, they're 180. Or if it says complementary, you'll say, oh yeah, they're supposed to be 90, okay? So have a great day, and I'll see you next video. Bye.